Hi everybody, today we're going to do day 1 of Unit 10, which is all about quadratics. So, quadratics, we're mostly going to talk about how to find solutions for those kind of functions, and what the graphs look like, and then dealing with word problems and stuff like that. Okay, so today we're just going to be talking about, it's an introduction to quadratics, what they look like, and a little bit on how to graph them. Okay? So a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. Okay, so very similar to the polynomials, it's going to be a trinomial. It's going to have a degree of 2. Okay, but what's really important is that the a, which is at the part of the first term, which is the x squared part, that cannot be 0. So for it to be a quadratic, it must have that x squared part. Okay. For a parabola, it's the graph of a quadratic function, which is a U-shaped curve, and the curve's symmetric. So this is my very poor attempt at drawing a coordinate plane, okay? And this is also my very poor attempt of drawing a parabola because it's not symmetric. This is what happens when I draw on a computer. But as you can see, it's U-shaped. It can either open up or it can open down. This is a little bit better one, but the graph still is horrible. Okay? Now there's 3 different ways we can write the equation for a quadratic. First one is standard form, which is what we're going to focus on, standard form. Okay? Factored form just means taking that trinomial and factoring it. So you have 2 factors. And then vertex form, which you really won't see at all. It's part of an honors topic, so we'll probably see it after SOLs for the honors classes. Just talk about it. It is this, where H and K make up the vertex. You will see factored form a little bit, but our whole goal with factored form is to change it into standard form, or to be able to factor the standard form and figure out the factors. So we don't really use factored form that much, except to help, aid us in answering a question. Standard form is typically how we are going to leave our answer. Okay? The axis of symmetry is the vertical line that splits the curve evenly. Okay, so that's the folding line that you can fold your curve around, and they'll line up perfectly. That's what makes it symmetric. Okay? We write it as a vertical line, like the equation for a vertical line, so it's going to be x equals whatever that number is, which is also the x-coordinate of the vertex. Your vertex will always be on that axis of symmetry. Okay? Now we've talked a lot about vertex. How about we talk about what it means? The vertex is the lowest point, which we call the minimum, or the highest point, which we call the maximum of the parabola. So if you go back to these, this has a maximum because that's the highest point of the curve. Okay, that's also where I'm going to draw my line of symmetry. This one, which is a little wonkier, that's my vertex. Because it's the lowest point, that's my minimum. My line of symmetry would go right through there. Okay? So the parent function for a parabola, remember the parent function is the most basic thing. Told you the only thing you really need is that x squared. So the parent function is the x squared. Okay? And this is what it looks like. Again, my computer drawing is really bad because it doesn't like to listen to me. So what it is that the parent function goes to the origin, okay? And then if you just plug in numbers for x squared, you can plot your points. So I plugged in 1, 2, and 3. So 1 squared gives me 1 for the y. 2 squared gives me 4 for the y. 3 squared gives me 9 for the y. So they grow, okay, making that U shape. But if we do the negatives of those numbers, we still get the same y. So negative 1 squared still gives me 1. Negative 2 squared still gives me 4. And negative 3 squared gives me positive 9. Okay, so that's what makes it symmetric, is that it doesn't matter if it's positive or negative, it's still going to get the same y placement. Okay, so my U shape should be going through all 5 or 6, 7 of these points, but my drawing wouldn't for whatever reason. So when you draw this, just make sure it goes through all those points. Okay, so that's just an example. That's just showing what the parent function is. If the a, meaning the number with the x squared, is greater than 0, the parabola is going to open up, and it's going to have a minimum, just like this one, because this one, the a is 1. If a is less than 0, meaning it's negative, it actually opens down and has a maximum. If a is greater than 1, it actually means it's going to be a wider parabola compared to the parent functions. And if it's less than 1, it's going to be thinner than the parent function. So if it is 1, it's going to be the same width of the parent function. It's just going to be moved up or down or left or right or something. It's still going to be the same shape. Okay, so just some characteristics. And moving on. So zeros, remember we talked about zeros before. Zeros are x-intercepts, also known as roots. You'll hear them be called roots a lot. Or solutions. So we actually use roots and solutions a lot more in this unit than zeros or x-intercepts. Parabolas can have 1, 2, or 0 solutions. So an example of one solution would just be the minimum or maximum just touches the x-axis, so it only is crossing at one point, because that one point is the only thing touching the x-axis. 2 is if it's crossing twice, so both arms of it go through the x-axis, and 0 meaning it doesn't cross through the x-axis at all. Okay? Graphing a quadratic. There are a couple things you need when you are graphing a quadratic. One, you want to start with the axis symmetry. Once you figure out what that is, you actually get a vertex, okay? And once we have the vertex and the axis symmetry, we can just like plug in x's to get the y's to get the other points for the thing. So, axis symmetry, I was supposed to click on this before. It has a formula. We can get that number that vertical line is going through by doing the negative of whatever b is over 2 times whatever a is. So here in this equation, a is actually 1 and b is 4, because that's the coefficient for the middle term. So we go ahead and plug that in. We get the negative of 4 over 2 times 1. That just means negative 4 over 2. So the axis symmetry is at negative 2, right here. Okay? That means my vertex is on 2. So the x part of my vertex, which is just a point, is negative 2. It's going to be somewhere on this line. So all we have to do is find the y. To do that, I'm just going to take the x value, plug it in for all of these x's to find my y value. Okay? And then just simplify. So negative 2 squared gives me 4. Negative 2 times 4 gives me 8. So 4 minus 8 minus 5. The y value is actually negative 9. So I can plot a point right there as my vertex. Now that I have that stuff, because I'm definitely going to need a vertex to like draw my parabola, and the line of symmetry so I know how it how symmetric it is, I'm just going to make a table. So I literally just am making a table x and y, and I just picked a bunch of x's. So my rule for x's is that you want to pick x's that are on either side of the line of symmetry so you can get the basic shape on both sides. So I picked negative 5, negative 3 because that's on the left side of negative 2, and negative 1 and 1 because it's on the right side of negative 2. So again, take your x values, plug them back into the equation just like we do with the vertex, and you'll get the y's. Or you can always put this equation into the calculator and go to the table part, and then you can just look at the table to get these things. So I got negative 5, 0, negative 3, negative 8, negative 1, negative 8, and 1, 0. So if you notice that negative 5 and 1 both cross the x-axis at 0, okay? Or when y is 0, whatever. It's because they have the same y value because they are equidistant from the axis of symmetry. So what that means is that as long as they're the same distance away from that axis of symmetry, they're going to have the same y value. So if I found negative 5 and I knew that was 3 spaces away from negative 2, I can go in the other direction, and it's also going to have a 0 for y. So at 1. Okay, so I can cut down my work in half if I wanted to. Or you just do it, it's fine. Then I just go ahead and draw my clicky thing. I'm just going to put it in place. Draw my parabola and connect dots, and that's all I do. Okay, so you guys are going to try this one on your own. Alright, and we are going to move on to the next one. So when you're writing an equation from a graph, this way I think is a little bit easier. You're going to find the zeros of the graph, and just set them equal to x. So it's like x equals this, x equals that. Then what we're going to do for each of those equations that we have, those x equals, we're actually going to get it so it something equals 0. So we're actually going to move the number to the other side with the x. And whatever equals 0 is actually a factor, like part of the factored form of that quadratic. So then we just multiply the factors together to get standard form. So let me explain. Zeros here are at 1 and 3, okay? So we're just going to set them equal to x. So x equals 1 and x equals 3. Then we're going to try to get it to equal 0. So we're going to move these numbers over. So I subtract 3 from both sides, so I get x minus 3 equals 0. That I want it to equal 0. Do the same thing for the 1, subtract 1 from both sides. I get x minus 1 equals 0. These things that equal 0 are our factors, okay, of the polynomial. So I can write it like that. Factored form just means to put an y in front of that, y equals that, which is great, because if they just want an equation, that's your equation. However, in algebra, we're going to be focusing more on standard form, so all we have to do to put it in standard form, meaning to look like that trinomial, is multiply these two factors. So you can use FOIL or Punnett square, like what we did last unit. I use FOIL, so first gives me x squared, last gives me -3, -1 times x gives me my inner, and last is 3. Then I just combine like terms and make sure the y equals part is there. I get standard form. Okay? And you guys are going to try this one on your own as well. Now, I goofed and did not pay attention to the parabola that I picked because it's not really crossing at a nice place. So we're just going to go ahead and budget and say that the zeros are -5 and 1 because that's the thing they're closest to. Work with those zeros and try to get standard form. Okay? Alright, good luck, and if you have questions, we'll talk about them in class. See you later.